You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine handing over the company checkbook to this brilliant, lightning-fast employee.
Right.
Like they work around the clock, they never take a coffee break, and they are desperately eager to please.
Always a catch, though.
Exactly. The
Yeah.
catch is they have absolutely zero concept of money. So every
Yeah.
time they make a mistake, they just frantically spend more cash trying to fix it before you notice.
Which is terrifying because you get the sheer speed of automation, but you're also, footing the bill for every single misstep magnified by 1,000.
Yeah.
And that's really the ultimate double-edged sword we are dealing with in data engineering right now.
It really is. And welcome to the deep dive. Today we're looking at a massive stack of curations from TLDR data, specifically their newsletters from June 15th and June 18th, 2026.
Lots of really technical stuff in those two.
Oh, packed. So if you're listening right now, maybe you're a data engineer trying to hold a tech stack together, or maybe you're just looking at the industry and wondering why so many AI implementations are just going completely off the rails.
Yeah, going up in flames, basically.
Right. So our mission for this deep dive is to map out the current state of data engineering and really separate the hype of AI from the actual gritty infrastructure you need to run it in reality.
And the common thread across all these sources is this massive pivot. I mean, the industry focus has shifted entirely away from building standalone models.
Right. It's not about the model anymore.
Exactly. The real challenge now is building the ecosystems to contain those models, to keep them from bankrupting companies or hallucinating wildly when they touch actual business data.
So let's look at those runaway budgets first, because the honeymoon phase of just letting AI agents loose is officially over.
Completely over.
The starkest example here is Uber's recent AI budget blowout.
Hmm?
They rolled out Claude Code across like 84% of their 5,000 engineers.
Which is massive adoption.
Incredible adoption.
Hmm.
But they completely exhausted their entire annual AI budget by mid-April.
Wow.
3.5 months in, and the money was just gone.
And the critical thing to understand about Uber's situation is where that spend actually went. It wasn't raw compute dedicated to, solving complex problems.
Where was it then?
The spend was hidden in the orchestration layer. Think about how an AI agent works under the hood. It writes a script, executes it, and if it fails...
It just tries again.
Right, but it appends that error to its context window first. Every single retry forces the model to reprocess an increasingly massive context window.
Oh, man. So you're paying for that exponentially growing prompt every single loop.
Exactly. A task that should cost 2 cents ends up costing $4 because the agent just, panicked in a silent loop for 20 seconds.
That's wild. And Wes McKinney actually explores this in his essay, The Mythical Agent Month.
Oh, that's a great piece.
Yeah, he points out that while these agents drastically reduce the manual labor of typing out code, they do not reduce the need for architectural design.
Right, or scope control.
Exactly. Agents are generating technical debt at what he calls machine speed.
Which is a fundamental shift in bottlenecks. The limiting factor in software development is no longer the physical act of writing syntax, it's steering the logic.
Because an agent doesn't know when a workaround will conflict with a downstream service.
Precisely. Agentic AI is no longer a token pricing problem. Token prices are, dropping to the floor. This is now a task economics problem.
But wait, if agents are generating technical debt at machine speed, aren't we just building a giant maze of spaghetti code that human engineers will eventually have to clean up?
That is the exact fear.
If an agent can write 1,000 lines of unoptimized pipeline code in 5 seconds, the cleanup cost just feels like a ticking time bomb.
And that fear is what's driving the push towards stateful infrastructure. Look at the Databricks aparse document function they highlight in the sources.
Yeah, the one that extracts data from PDFs.
Right. On the surface, it's magic.
Yeah.
You use an LLM to turn a messy PDF into a clean JSON structure with just a few lines of SQL. But the mechanism underneath is deeply problematic for a production database.
Because every time you rerun it,
it reopens the parsing workload. You incur those LLM API costs all over again.
even if you set the model to temperature 0, like the absolute least creative, most predictable setting, and LLM is inherently non-deterministic.
Exactly.
You might get a slightly different JSON structure on Tuesday than you did on Monday, which just ruins your auditability.
And you cannot build a trusted data warehouse on non-deterministic foundations.
Yeah.
Which is why we're seeing this push for deterministic alternatives, right? Like the
Yeah.
open source open data loader for consistent PDF extraction.
Or smaller, localized data agents, like probably.
Right, because they give you the natural language analysis without the massive, unpredictable cloud loops.
So if these agents inherently want to run wild, you essentially have to build walls around them.
Yes, exactly.
The sources call these context layers, or meta-harnesses. One article even argued that a frontier model without an ecosystem is not stable.
You really have to own the workflow. Spotify's rollout of their AI data assistant, they call it Better, is a perfect case study for this.
Yeah, they built Vetter to serve, over 2,100 users across 70,000 data sets?
Yeah, but they didn't just point a large language model at their warehouse and hope for the best. They employed human domain experts to rigorously curate it.
And the metric here is insane. Only 12.5% of the automated query pairs mined by the system were actually accepted into production by those experts.
Right, they threw out nearly 88% of what the AI assumed was correct.
That really puts the intelligence part into perspective, doesn't it?
It really does. The AI was likely generating queries that were syntactically perfect SQL, but semantically meaningless to the business logic.
So Spotify had to institute strict health scoring for query drift and reproducibility.
And we are seeing this curation layer become a formal product category now. Like Databricks launched Omnigent, which is an open source meta harness.
And what does that actually do?
It sits above your individual agents, whether that's Claude, Codex, or Pi, and it enforces a unified security and cost control layer before they can touch your data.
Okay, and MotherDuck is doing something similar with flights, right? Giving
Right.
agents a secure Python runtime for ingestion workloads.
Exactly.
So we're essentially building middle management for AI.
Yeah.
But if Spotify has to manually reject 87% of queries, and we need tools like Omnigent to babysit them, doesn't this strict curation kind of defeat the promise of an autonomous agent?
Well, autonomy without boundaries is just noise. The LLM itself is really becoming a commodity reasoning engine.
Right.
The actual intellectual property, the true value, is the curated ecosystem connecting that model to your highly specific business logic.
Like Rippling.
Yes, Rippling. They completely rebuilt their go-to-market data foundation. They set up a medallion architecture, turned it into an AI database, and put a natural language Genie interface on top.
And to the user, the Genie seems autonomous.
But it only functions because it operates within a hyper-curated, rigid framework.
Which brings us to the bedrock of that framework. Because even with a harness, if the raw data underneath is flawed, the agent just fails.
Oh, absolutely. The sources call this the identity crisis, pointing specifically to entity resolution and warehouse native master data management, or MDM.
Right, dealing with phantom entities and duplicate customers. It's like having a supercar, but your GPS sends you to 3 different addresses for the same person.
That's a great way to put it. Entity resolution is like trying to assemble a massive graph network, but millions of nodes are slightly misspelled.
And if a traditional BI dashboard double counts a customer because of a spelling error, a human analyst will probably spot it.
They'll see the anomaly.
Yeah, but an AI agent lacks that common sense. It treats those 2 fractured records as distinct truths.
And then it poisons its own reasoning chain. It hallucinates an entirely false narrative.
But is identity resolution really an AI problem? Or is this just a classic database chore we keep ignoring because it's boring?
It's the core of the AI problem. Bad identity data equals hallucinating agents. You cannot have trusted AI products without warehouse-native identity resolution. You need ML matching, graph clustering, and human review.
And the scale is just staggering. Look at Salesforce's Data 360 segmentation engine, processing 1 quadrillion records a month.
Quadrillion. It's hard to even conceptualize.
But the wild part is, what actually broke wasn't the processing of the records, it was the metadata.
The system choked on the map, not the territory. When you have a schema that complex, the metadata payload describing the table relationships hit over 500 megabytes for a single environment.
Just for the metadata.
Right. And the query optimizer has to sort through billions of candidate query plans before reading a single row of data.
The database engine literally collapses under its own administrative weight.
Exactly.
Which is why the way AI searches for data is evolving so dramatically.
Yeah.
The sources highlight a shift toward GPU workloads for inference pipelines dealing with video, audio, and sensor data.
We're moving away from CPU-centric SQL ETL, and Instacart's complete rebuild of their ads retrieval system is a brilliant demonstration of this.
Oh yeah, they used to use a BERT model, right?
Right. which handles retrieval by scoring. It essentially evaluates every single product ID and assigns a relevant score.
Grading tens of thousands of items just to pick the best match.
It's computationally exhausting, and it struggles with cold start problems like when a brand new cereal hits the database.
So instead, they replace that with a generative model that spells out recommendations token by token using semantic IDs. Spelling it out instead of picking off a list is like generating a custom recipe rather than pointing at a menu item. But doesn't spelling risk hallucinating a product that doesn't even exist?
That's the brilliance of semantic IDs. The model isn't generating English words, it's generating tokens that map strictly to a hierarchical catalog index.
Oh, like the Dewey Decimal System.
Exactly. It mathematically traverses a predefined tree structure, so it blends generative AI's flexibility with database rigidity. It physically cannot generate an ID outside the catalog.
That's incredibly clever. And LinkedIn is using a similar trick with their MUS system member understanding semantic embeddings for their hiring assistant.
Yes, they use dual tower matryoshka embeddings.
Like the nesting dolls.
Right. Normally, an embedding is a massive vector. If you shorten it to save compute, you lose the meaning. But Matryoshka embeddings front-load the critical information.
So you can crop out 80% of the vector for a fast search, and it still retains the core semantic picture.
Just at a lower resolution. And LinkedIn trains this using an LLM teacher tightly grounded in their policy.
Speaking of grounding, Heidi AI achieved frontier model parity just by fine-tuning a smaller clinical model using real clinician feedback loops.
Tighter loops, nested embeddings, generative semantic IDs. But to support all this real-time semantic search, the underlying architecture has to change.
Right. There's a webinar mentioned with Matias CEO Benjamin Segal and data strategist Doug Laney, where they admit the current data stack is basically held together with duct tape.
It just wasn't built for continuous machine-speed AI queries, which explains the mass migration from Hive-style data lakes to Apache Iceberg.
Iceberg uses S3 tables for time travel and highly efficient pruning.
And Databricks is pushing latency down with Lakehouser T, powered by Raiden, delivering millisecond queries directly on Lakehouse data.
No moving the data around. But the most radical shift mentioned is Feldera. It treats streams as incremental SQL views, using DVSP-directed big graph stream processing and ZSET changes.
Yeah, that's a lot of jargon.
Exactly. We hear real-time every single year. So for you listening right now, is Feldera actually changing the game, or is this just more vendor jargon for faster databases?
It actually is a paradigm shift. To understand why, look at a ZSET. Historically, you either ran a slow batch job every night or built a fragile event streaming pipeline.
Right.
A ZSET is algebra for databases. Instead of recalculating a massive table when new data arrives, Feldera calculates the mathematical derivative of your SQL query.
So if one row in a billion-row table changes, it only computes the math for that specific update.
Yes. You write standard batch SQL, but the engine runs it continuously and incrementally. It fundamentally changes the latency profile.
And we are seeing performance leaps everywhere. Apache Data Fusion 54.0.0 just dropped, making sort merge joins up to 50 times faster.
And people are building DIY feature stores from scratch using just DuckDB and Redis.
But as things connect, governance becomes the nightmare. Guidewire used Apache Trino to federate queries across Iceberg, Redshift, OpenSearch, and S3.
Which is incredibly powerful.
It is, but it exposed a massive Trino RBAC gap role-based access control. If a user can see a column in Redshift, but not Iceberg, how does the federated engine resolve that in real time?
That need for standardization is why the Linux Foundation launched the Open Sharing Project, taking Databricks Delta sharing and standardizing AI asset exchange across clouds.
Because as the DBE Labs State of Analytics Engineering report confirmed, the real priorities for data teams aren't just speed, it's trust, governance, and cost.
Which brings us to the final hurdle. You have this blazing fast, agent-driven infrastructure. How do you actually audit it?
How do you keep it safe? OpenAI's new deployment simulation is a brilliant approach here.
It really is.
Before releasing a model, they take real, de-identified user conversation prefixes, just the beginnings of prompts, and feed them into the new model to simulate its behavior in the wild.
Which is far better than static, multiple-choice benchmarks.
It's basically a fire drill for AI. And while OpenAI tests behavior, Google Research introduced a framework for auditing machine unlearning.
Right, using regularized F-divergence kernel tests.
But wait, Regarding machine unlearning, is it genuinely possible to make a neural network truly forget a piece of data? Or is Google's tool just checking to see if the AI is good at hiding it?
That's the core question. Masking just slaps a filter on the output, but the underlying weights still contain the data. The mathematical complexity here is immense.
So how does the test actually work?
An F-divergence kernel test evaluates the statistical probability distribution of the model itself. It mathematically compares the footprint of the unlearned model against a hypothetical model that never saw the data at all.
Oh, wow. So if the statistical divergence is 0, you've achieved true unlearning.
Exactly. And privacy leakage like that is the next massive frontier.
Although sometimes the biggest risks are just classic, silent data failures. The newsletters mention data pitfalls, an open-source Claude-powered tool that audits charts and reasoning chains for bias.
Because a frontier AI is useless if the SQL query feeding it is broken, there's a great call-out to a classic PostgreSQL gotcha.
The NOL, in a not-in subquery.
Yes. The database's three-valued logic evaluates the whole condition as unknown, returning 0 rows. The AI agent will confidently assume the data simply doesn't exist.
Or a query accidentally triggers a full table scan and brings the database to its knees, which is why PGK-part was released to block partition table queries that fail to prune.
Sometimes you just need to visualize the chaos. That free browser-only SQL to ER diagram tool they linked is incredibly handy for mapping out messy schemas.
Yeah, we have covered massive ground today, from Uber blowing its AI budget on silent retry loops to building meta-harnesses like Omnigent and Instacart spelling out semantic IVs.
Not to mention identity resolution and unlearning simulations.
Exactly. So what's a big takeaway for the data engineer listening to this?
It leaves me with a thought that wasn't directly in the sources, but feels inevitable. If AI models eventually write their own queries, spin up their own incremental views in Feldera, and negotiate with each other via Omnigent,
Yeah?
will the human data engineer of the future stop being a builder and instead become an AI therapist?
Oh, man.
Managing the psychology, the economics, and the governance of these machine-to-machine workflows.
An AI therapist. Managing the hyperactive, brilliant employee with the corporate checkbook. That is a fascinating way to look at it. Thank you for joining us on this deep dive. Keep questioning the data behind the hype, and we will catch you next time.
Spoken Tech, for your ears.